The universe is not required to be in perfect harmony with human ambition. Carl Sagan. Please watch to the end. The most interesting part is at the very end. Primnoa resedaeformis, commonly known as red tree coral, is a deep-sea octocoral belonging to the family Primnoidae. It inhabits cold bathyal waters of the North Atlantic, particularly along continental slopes and submarine canyons, at depths where sunlight is completely absent. In this environment, life is governed by current flow, temperature stability, and long-term persistence rather than rapid growth. The coral forms large, tree-like colonies that can exceed 1 meter in height. These branching structures are anchored firmly to hard substrates such as bedrock or boulders, allowing the colony to remain upright in strong bottom currents. Unlike tropical corals, Primnoa resedaeformis does not rely on symbiotic algae. All energy is obtained through suspension feeding, capturing organic particles and plankton carried by deep-sea currents. The skeleton of Primnoa resedaeformis is composed of a proteinaceous gorgonin matrix reinforced with calcite sclerites. This composite structure provides both flexibility and strength. The branches can bend under sustained current flow without fracturing, a critical adaptation in regions where currents are persistent and sometimes intense. Life adapts not by speed but by persistence. Jacques Monod. A lesser discussed anatomical feature lies within the internal canal system of the branches. The axial skeleton contains microscale longitudinal channels that allow limited internal fluid redistribution when the colony is bent by currents. This reduces localized mechanical stress at branching points and helps prevent structural fatigue over decades. This feature contributes to the extraordinary longevity of the species, with individual colonies estimated to live for several centuries. Each branch is covered with thousands of small polyps equipped with tentacles lined by nematocysts. These tentacles extend into the water column to intercept drifting organic matter. Feeding occurs continuously, but at a low metabolic rate, reflecting the energy-poor conditions of deep-sea ecosystems. Ecologically, Primnoa resedaeformis functions as a habitat-forming species. Its complex three-dimensional structure provides shelter and attachment surfaces for numerous invertebrates and juvenile fish. In many deep-sea regions, entire biological communities are organized around these coral colonies, making them foundational elements of benthic ecosystems. Reproduction in Primnoa resedaeformis involves the release of gametes into the water column. Larvae disperse with currents before settling onto suitable hard substrates. Growth is extremely slow, measured in millimeters per year, and recovery from physical damage can take centuries. The vulnerability of this species is closely tied to its biology. Because of its rigid attachment to the seafloor and slow growth, physical disturbance such as bottom trawling can permanently remove colonies that took hundreds of years to form. In this sense, Primnoa resedaeformis represents not just an organism, but a long-term geological-scale investment of biological time. The history of life is written in structures that endure. Stephen J. Good. If this changed your understanding of deep-sea ecosystems, please support the channel. Like the video, subscribe, share it, and tell us in the comments which deep-sea organism you would like to explore next. Let's discuss in the comments.